Now the next part of section 3.1, or I should say lesson 3.1, is about descending order and degree of polynomials. Now, two things. So now that we've figured out how to find the degree of each term, we can put terms in order. And generally speaking, when we write a polynomial, we put it in descending order. What that means, well, let me give you an example here. What that means is that we're going to put the highest degree first. So like when we dealt with 3.1 part B, when we started with x to the third minus 3x squared plus 3x minus 1, notice that this term was degree 3, this term was degree 2, this term was degree 1, and this term was degree 0. That is in descending order. 14 minus d is not in descending order. 14 is degree 0, d is degree 1, and so this is not in descending order, but x to the third minus 3x squared plus 3x minus 1 is in descending order. And so what we like to do is put things in descending order and then state what the degree of the polynomial is. Now here's why that descending order is really nice. The descending order is really nice because the degree of the polynomial is the highest degree on any term. So if we put things in descending order, the degree of the polynomial is the degree of the first term. So for instance, in this problem here, we already said that this is in descending order, but the degree of the first term is 3. So the degree of this polynomial is 3. By the way, there's also something called the leading coefficient. The leading coefficient is the coefficient of the polynomial once it's the first coefficient of the polynomial once it's put in descending order. So it's the coefficient of the term of highest degree. So this number 4 is in descending order. Its degree is 3, and the leading coefficient we would say is 1. 12 is not in, I mean, did I say 12? 2 is not in descending order. 3 is in descending order. 1 is by default in descending order. There's only one term. So hopefully that makes sense. If it does, what I'd like you to do is I'd like you to push pause on the video, and in these 3.1 cooperative group problems that are on page 117, I want you to put each polynomial in descending order. Then state what the leading coefficient of the polynomial is, and then state what the degree of the polynomial is. So go ahead and push pause on the video, and then I'll explain those. All right, here we go. So descending order on problem number 1. The descending order is 4x squared plus 3x plus 5. So we go with the term 2, term of degree 2 first, then the term of degree 1, and then the term of degree 0. The leading coefficient, therefore, is 4, because 4 is the coefficient on this x squared term. And then the degree of the polynomial is 2. Now again, that's the degree of this first term. You do not have to add in or involve this x here because it's not being multiplied by this x squared. So again, that's a little bit of a distinction from what we did when we multiplied all of it. So descending order, 4x squared plus 3x plus 5. Leading coefficient is 4. Degree of the polynomial is the degree, the highest degree of the terms in that polynomial. All right, let's take a look at number 2, 17 plus h. Well, that should look fairly familiar. That's something we dealt with before. So h plus 17 is the polynomial written in descending order. That means the leading coefficient is 1, and the degree of the polynomial is also 1. Again, we're focusing in on this first term, which is h. The coefficient of h is 1. The exponent on h is also an implied 1. On problem number 3, descending order, we have to start with the highest degree term. So we're going to start with the 7a to the third, and then we're going to have 8a squared, and then a minus 4. By the way, be careful that the minus travels with the 4 and is still with the 4, and the 8 and the 7 stay positive. So there you go. Leading coefficient on this polynomial is 7. The degree of this polynomial is 3. Again, once we've put things in descending order, then essentially what I'm going to do, oops, I was trying not to just highlight that. Excuse me. Essentially what I was trying to do, see if this will work. Nope, didn't do it. So, is focus on that 7a to the third. So 7a to the third plus 8a squared minus 4, leading coefficient 7. Goodness. Degree of the polynomial is 3. All right, next problem here says, do this. All right, says descending order. Now, this one, again, you have to be careful because when highest term is a p to the fourth, so, but this minus p to the fourth means that I need to make sure that that negative stays with that p to the fourth. Next highest degree is 7p squared, so plus 7p squared. Next highest degree is 4p. Next highest degree is a minus 13, which is the lowest degree, obviously. Leading coefficient is a negative 1. Again, that negative sign there is important, so negative 1. It's always an implied 1 in front of it if you don't, in front of the variable if you don't see anything. And then the degree of the polynomial is 4. So that is the fourth problem. 42, well, 42 in descending order is just 42. Nothing really extravagant there. Leading coefficient, again, 42. Degree of the polynomial is 0. There are 0 exponents in that. So this shows a couple of points here. Sometimes a polynomial is already written in descending order, so you don't have to do anything with it. This one obviously was a monomial, so the degree of the term was the same as the degree of the polynomial. And there you go. So that is how we deal with degrees of polynomials. All right, degrees of polynomials are the degree, I should say the degree of the polynomial is the degree of that leading term when we put terms in descending order.